I am Major Brittany Aletti, and I'm here from the United States Military Academy to talk a little bit about how we use Mathematica and these scaffolded tech labs that we've created to enhance student learning in our particular program. So a little bit of an introduction to our course. I teach in the advanced math program here at the United States Military Academy at West Point, and we have these advanced cadets who have taken calculus before, and they get to go into a special series of math where they would start in math modeling and ordinary differential equations. So this is their first course in math here at West Point. And then after they take math modeling and differential equations, they go into multivariate calculus. Out of the incoming class of about 1,200 cadets that we have each year, about 320 to 360 come into the advanced math program because they have the background to do so. And all of these cadets will come in their first semester, regardless if they have other classes planned. The audience is these first year cadets. I'll be using cadets as the term because that's what we call our students here. They have at least 1 year of calculus. Many have calculus AB, calculus BC, and some have even gone through multivariate. And for those who have done multivariate calculus, we give them an opportunity to test out in the spring semester. The other side of it, though, is while they're incredibly advanced in math, they have limited to no coding experience. So when we start trying to solve differential equations and we need some numerical approximations, they don't quite have the background they need to use things such as Python or Maple or MATLAB. They will eventually, while they're here, either their first, second, third, or fourth semester, take a class on Python. But when they first arrive to us in the advanced math program, they've taken no coding classes. So what is the motivation to having coding experience? Well, the technology allows them to solve more meaningful differential equations to visualize, and as well as in our multivariate class, we use it to visualize surfaces in 3 dimensions. All these things can be accomplished with a single line of code, which means that we are limiting the cost in teaching the cadets on how to use the program in order to actually be able to do the math more effectively. So I'm going to give you a little bit of an overview. We have 4 tech labs sprinkled throughout our course. And what you can see right now on the screen is our course schedule, and we're going to talk about block 1 first. And you'll see that we started our semester back on the 19th of August. And in the first block, you'll notice that on lesson 6, August 28th, it says Tech Lab 0. That is their first day dedicated to doing the technology lab. So they are given time in class to work on these. And that one is the introduction into Mathematica. And you'll see that later on in the block, they'll have Tech Lab 1 that covers first order differential equations. That's on September 10th. First order. And so in block 1, while they're revisiting calculus concepts, as well as learning first order differential equations, including analytical methods, direction fields, graphical methods, and numerical methods, they'll have exposure to Mathematica in both of these regards. So, there we go. So Tech Lab 0, the language that we do for these tech labs is very tutorial style. So I think of it as kind of like walking their hand and giving them code and showing how to interact with it. So they're walked through very slowly on Tech Lab 0, knowing that most of them do not have coding experience. And the main focus for this one is those predetermined functions, creating new functions, using reserved characters, capitalizing sine, cosine, and e. And then we have some emphasis placed on annotation, making sure they are doing annotation in their code so it's clean. And this is a skill that we hope that they take with them throughout their time here. The commands that we focus on for Tech Lab 0 include using the log command, plot, sine, cosine, tangent, using clear, integrate, and solve. This is all in Tech Lab 0, which is where we haven't touched differential equations yet, but we were doing a bit of a calculus review. So an example of our Tech Lab 0, these are the things that they should be outputting once they do the tech lab, is we work a little bit on plotting, and we have purposely selected sine and using pi to ensure that they understand that they need to capitalize the s in sine and capitalize p and pi, and to make sure that they're getting some sort of output plot. We'll be using plotting a lot in differential equations as well as in multivariate calculus. We also want them to be able to plot multiple things on one plot. So in Tech Lab 0, they'll eventually get to the spot where they have plotted cosecant e to the 4x and x cubed all on the same plot. And then after that, they've done a little bit of plotting, and in that multiple plots, we do have them do the plot legends expressions. We want them to be able to label their plots, and we'll introduce more plotting features in subsequent tech labs. Finally, we'll teach them how to do derivatives and integrals in Mathematica. So having them define a function, taking the derivative, evaluating both the function and its derivative at a particular point, And then we also introduce them to the palette. So we'll teach them the integration command, but we'll also show them how to use the integral from the palette, and then taking these solved expressions and plotting them simultaneously. You'll notice we have a lot of plots, not only because we plot a lot with our differential equation solutions, but also because in terms of like the instructor point of view, it's a lot easier to grade a plot than it is to go line by code. Once I see that they have a plot that looks exactly like this, I know that they've done everything leading up to it correctly. And finally, the thing that we have them do in Tech Lab 0 is identify points of intersection. So this is where they're using the solve command, and they'll use that a few times throughout the semester. And you'll see that we have them solve where the function is equal to 10, and then we have them plot both the function and the function 10 on the same plot so that they can verify that their solution is correct. They can see the 4 points of intersection that they have identified from their code. Next slide. Okay. So shortly after they finish Tech Lab 0, we immediately assign Tech Lab 1. It'll be released to them, but they will also get another day to work in class on the Tech Lab. So Tech Lab 1, the language is still tutorial style, but it's a little bit less tutorial. So we are slowly pulling back those training wheels on them and giving them more exposure. And so that way, by the end of our scaffolded Tech Labs, you're able to just kind of run and use Mathematica without the hand holding. In this Tech Lab, we actually do force errors in the code. So we tell them to type something and it causes an error. And then we say, oh no, what should we do? Let's read what the error outputs and troubleshoot it, and direct them to kind of troubleshoot their own code. This is another skill that we hope that they continue using throughout their time here. The main focus for this Tech Lab is solving first order differential equations, using more plotting options, using lists, and we actually made a pre-made module for them. So they get the module, but it's actually running the module that we want them to do. And that particular module is Euler's method and improved Euler's, which I'll be showing you in a minute. But that's our numerical approximations of differential equations, which is something they learn in the first block in our course. We continue emphasizing annotating their code. This is a really important skill for them to have. You'll see that in all of our Tech Labs. The commands that we focus on are list plot. We do a little desolve value. This is where we're actually solving our differential equations, showing multiple plots, additional plot options such as label, style, and range, and then finally the module. So for the sample, the first thing we do is solving these differential equations and troubleshooting. So you'll see that I have 3 different functions here, f of x, g of x, h of x, and they're all being solved. Well, 2 of them are being solved by desolve values. So we have them solve that, and then we say, solve when it's equal to 1/2. And I'm going to run it, and hopefully it works in real time. And it says here, oh no, the system can't be solved with the methods available to solve. What do we do? Well, it tells you exactly what you should do, right? It says, try, reduce, or find an instance instead. So we told them in the Tech Lab, hey, you're going to do this, and now there's going to be a problem. You should use the troubleshooting notes to fix this. And so what they end up doing is they end up using find instance, and they're able to solve for it. Other things that we have them do in this Tech Lab is we start having them use lists. We're going to use lists later in Tech Lab 3 and in their project. So it's really important that they have example using lists. So we give them a pre-made list and we ask them to plot it. And then we give them some functions and we say, now plot a list with all those data points with those functions and tell us which one best fits the data. Later, we'll be doing fitting curves to data. So we want them to be able to put both a list plot and a function on top of each other to identify how well they're working. And then finally, for Tech Lab 1, I mentioned earlier, we do numerical methods. So we created a module called Euler's method, and it's just, we don't have them adjust anything in this block of code. We say, this is given to them in a Mathematica notebook, and we say, your job is to use it. Your job is not to modify it inside of the module. So we have both the Euler's method and improved Euler's, and then they have to create this function for themselves based off of what we get, and then they have to create a function for them in the Tech Lab and determine their initial condition and what their step size are and what their final value is. And when they go through, make sure that we have this running correctly, run the modules in the background, they should get a list of values, right? And I have it named sol-em, and I'll show you why in a minute. So they'll solve and they'll get their numerical approximation, which saves them computationally quite a bit of time if you've ever done Euler's or improved Euler's. Once you have more than 3 step sizes, it gets really dicey. And then this is their improved Euler's. So then what we have them do is we take the list that was developed from Euler's and we give them the exact solution to the differential equation. There is an analytical solution to this one. And then we have them plot the list for Eulers. The red dots are the result from the Eulers function, and the blue dots are the result from the improved Eulers, and then the green is the line. I know it looks like it's exact, and once we start to make the step size a little bit bigger, you can see that there's a difference between improved Eulers and the analytical function. So once they've gotten through all that, we get into block 2, which you might notice is actually right now. We're in block 2 right now. And in block 2, they have another tech lab, and they're also going to be doing these modeling application days. You'll be able to see on the calendar, such as on September 26th. MAD 1 is the modeling application day, and I'll talk a little bit more about that one later. But they'll do tech lab 2 here. And in block 2, we're talking about systems of differential equations. So everything that we're doing in this block is geared towards solving linear and nonlinear systems of differential equations, both homogeneous and non-homogeneous, but with constant coefficients. So tech lab 2, the language is more direct. We say do the thing, but we don't necessarily hand walk them into the equations, and we point them to Mathematica's help feature. We say, go look at Mathematica help, look up the function, and determine how to use it. And we might say things like, for the plotting, make it orange. I'm not going to tell you how to make it orange, just make it orange because I like orange, right? This makes them go look in Mathematica's help features. That way they have that skill as they are developing through their undergraduate here. We also introduced the manipulate command. This will also help them later in their project, which I'll touch on a little bit more later. And the main focus here is just solving the systems of differential equations, understanding stability of differential equations, and solving nonlinear systems. We're going to be combining different plot styles, also to draw conclusions about particular solutions of DEs. Commands that we do in this one's a little bit more robust. We have D-solve value, row reduce. We have to introduce them to matrix stuff, even though it's differential equations class, because most of them haven't had linear algebra. Eigensystem, ND solve value, stream plot, manipulate, parametric plot, and show. So some of the things that we have them do here, what you can see on your screen right now is our manipulate stream plot. So we have them manipulate the stream plot. I put in a DE and a variable right here for the y prime, and I have them go through and take a look at, well, what do we see as we vary s? Well, here I see a spiral, so there must be complex eigenvalues, and I continue varying around. I love this little play feature where I can see all the different types of stabilities, and you'll see real repeated, real distinct eigenvalues, and complex eigenvalues all happening in the same stream plot. So then we tell them you must set it equal to particular values, find the eigensystem for each of those, and then plot it again and label it. Make sure you're labeling if it's an unstable spiral. That means that we have complex eigenvalues. The next thing we do for our nonlinear systems is we do, one of our biggest examples we use is the predator-prey modeling. So we have them use the ND solve to numerically solve the predator-prey model. And then we plot the solutions, right? So we have the moose and we have the wolves in this case that we gave them. And then after they've done that, we ask them to do a stream plot and a parametric plot, and we'll have them overlay it. So they'll do a stream plot to see what the behavior of the system is. You can see there's a nice center in there. And then we give them an initial condition. I believe it's 20-40 for this one. So 20 moose, 40 wolves. And they are supposed to plot that initial condition into overlay it on their face plane so that they can see what's happening with the wolf and moose population as T varies. So obviously it's very cyclic behavior here, but they have to be able to draw conclusions about what the x-axis is, what the y-axis is, and what this means in terms of population. Finally, block 3 is our higher order differential equations. Our biggest applied thing that we have in higher ordered is spring mass systems. So it's in a second order that involves a spring mass or spring constant, variable dampening, and a mass. And we'll use that information inside our Tech Lab 3. This is also going to help us put our finishing touches on some of our skills before we move into the project block. So it's very directive language, less tutorial, less hand-holding. We're going to build on the skills that they've developed before, prepare them for their project, and our main focus is solving these higher order DEs and also fitting data and using that to do some parameter estimation for DEs. So this one's a little bit of a shorter one. The spring mass system IVP is one of the things that we have them do. So it's a second order. We're using D-solve value again, not too much more than before, just making sure that they're doing the IVP component and including their labels. We also have them do the spring mass system with manipulate. We set the mass as a specific amount, but then we have them vary their dampening coefficient and their spring mass constant. And what this does is it helps them determine, well, when would a system be underdamped? When would it be overdamped? When would it be critically damped? and those conditions for beta, all those. Finally, we give them a list of numbers. We made like a logistic list and introduced using Mathematica some random noise in there to make it a little bit noisy so it's not perfect. And we're trying to fit the data using different things such as a line, a parabola, or a cubic using the fit function, and eventually having the cadets plot not only the list, but each of those, the line, the parabola, the cubic, and eventually get to the logistic. So that way it fits the data a little bit better. And then on the choice, sorry. Okay. So what does this do? Well, these Tech Lab 0 and 1 help prepare the cadets for that modeling application day I mentioned earlier. That modeling application day is focused on an exponential and logistic growth for tumor in a hamster. So they're able to use Mathematica to manipulate the numbers, to solve the differential equation, to make some estimations about what would happen as time goes to infinity. And then we also have them adapt it to include some sort of parameter for chemotherapy. Just exploratory in that regards. Tech Lab 2 prepares the cadets for MAD2, which is a modeling project that's focused on the Lancaster equations. Those are a set of differential equations that model a battle, and we specifically give them the Battle of Bulldog Bight from the Kandahar province in Afghanistan. So in the background, right, you see that I'm military. We like to give them military applications when we can. And so it's really exciting. They get really excited when they can do differential equations and actually apply it to something that's Army related. And Tech Lab 2 allows them to work through some of these functions that they would need to be able to solve systems of DEs and also do these graphical representations with a vector plot to know what would happen if we adjusted initial conditions. Finally, Tech Lab 3 is that polishing lab that helps prepare them for their final project. They get to select the topic of their final project. Usually we push them towards doing some sort of system of differential equations, and Tech Lab 3 gives them those capabilities to fit and find parameters based off the data that they're able to find online. We use all of the skills that we build up in the class that we teach MA 153, the differential equations, and we use these skills in terms of Mathematica in MA 255, which is multivariate calculus. We don't have tech labs because we've built all the skills up, but we do have these block projects that require them to use Mathematica to solve things like three-dimensional volume, linear programming, some other things that they would need to do in multivariate calculus that we've already built. We also really like using Mathematica to visualize surfaces and planes and lines in three-dimensional space. So key takeaways. Integrating this technology as a learning aid has really helped us enable the cadets to develop a deeper understanding of these complex concepts such as Eulers, improved Eulers, and even differential equations and what a solution to a differential equation is. And we're also able to allow them to engage in the material a little bit more fully. Because Mathematica is so streamlined and it has nice commands, even a beginner can quickly grasp onto programming, which makes it super accessible regardless of how the cadets come to us at West Point. Moving forward, so one of the adjustments that we did in fall of 2023 was to give more of this walkthrough style. Previously, it wasn't a walkthrough, it was very direct and they had to figure it out themselves. So in fall of 2023, we started making the tech labs a little bit more tutorial-like that slowly backs off of the tutorial. And what you can see, AY 23, that's fall of 2023, and AY 24 is, AY 23 is fall of 2022. AY 24 is fall of 2023, and then this year we have fall of 2024. I don't have the data yet for, but we polled the cadets and we said, hey, how confident are you in using Mathematica to solve differential equations? And in 2022, before we made the adjustment, 41% of them were still not confident and only 5% of them were confident. Now, last year, when we made the first round of adjustments, we had decreased that non-confident population to 18% and you're confident to 12%. So we're moving right, which is great. And I look forward to collecting data this year to see how much more confident they are now that we've made slightly more adjustments. So now the cadets are a little bit more comfortable in using technology to aid in learning, which will be helpful for most of them because they all need to do some sort of engineering track here at West Point. So that'll give them the skills to build on. And for future, we hope to enhance the tech lab slightly more by introducing more opportunities for the cadets to encounter and troubleshoot errors because they do happen a little bit more often, and also to help foster resiliency. And the last thing that we want to do is kind of expand the range of available commands as long as it supports some sort of student learning objective without detracting from the overall goal of the courses. that is all I have prepared. I'm standing by for questions. Thank you so much for stopping by and listening to my talk. Somebody asked, can you please share your presentation notebook? I will absolutely share that with you guys after this session is over. Ahmed, thank you so much for your chat comment. I love teaching the computational parts with the Mathematica. And I love that you also created a similar lab with data modeling. And if you'd love to share that, I would like to see that as well.